The Juno spacecraft's instruments run on electricity. But how do you power it when it's millions of miles from the Earth? I mean, you can't very well run an extension cord. The Juno spacecraft is powered by light from the sun. I'm a little spacecraft. Sorry. These 3 solar arrays take light and convert it directly into electricity. This little motor is powered by a solar panel also. When we turn it toward the light, the motor starts to run. The light driving this panel passes through a rectangle this big. But as we move farther from the source of light, there'll be less and less electricity to drive the motor. If we're twice as far away, that same amount of light is now spread out over 4 rectangles. So the motor only has a quarter as much energy to run it. If we go out 3 times as far away, that same amount of light is now spread out over an area 3 by 3. So the motor only has 1/9 as much energy to drive it. At 4 times as far away, that same amount of light is spread out over an area 4 by 4. The motor's only getting 1/16 as much energy, so it's barely turning. Now, in the case of the Juno spacecraft, if it's in orbit around the Earth, it has 12,000 watts of electricity. That's enough to run this whole studio. But by the time it gets way out in orbit around Jupiter, these same solar arrays are only going to be able to produce 400 watts. If you had a hairdryer like this, it would run fine when it's near the sun. But as we moved out farther and farther from the sun, the hairdryer would have less and less energy available to it. In fact, a typical hairdryer powered by the Juno spacecraft out at Jupiter wouldn't have enough energy to run at all. But because the instruments on board Juno are so efficient, it's going to work just fine. Of course, you might wonder why you would take a hairdryer out to Jupiter to dry your hair. Well, you wouldn't. I mean, it's just to give you an idea of the power.